Hello and welcome. Today we're going to discuss Docker. Docker is a very popular tool in many tech companies. I use this software a lot during my time at Redfin. Docker is a very important skill in the industry, so it's crucial to master this technology. In this video, I'm going to talk about the fundamentals of Docker. I will also show you how to build and run a container from scratch so that you can understand how Docker works. Without further ado, let's dive in. So, what is Docker? Docker is a virtualization tool. It packs everything an application needs, including the source code, the dependencies of the libraries, and the operating system configurations, into a single unit called a container. With a container, the application can be easily distributed everywhere. The main goal of Docker is to improve the development and the deployment process of any software project. Let's say a team is building an application using four services: MySQL 13.1, Python 3.7, Redis 4.1, and Flask 2.3. Before containers, each developer needs to install these services in their own local machine. But there are two main issues here. First, each developer has a different operating system. Some operating systems are not compatible with the services that the application is using. Moreover, the installations usually take many steps. That means it's also prone to human errors. The developer may mess up one command and he may not be able to install the service. That means the developers may spend more time and energy on configuring and maintaining their workstations. But with containers, things become much easier. The developers only need to pull the Docker image from the internet and run a container in their local machine. The container will have everything it needs to run the service regardless of what operating system the developer is using. This way, the dev team can spend less time on installation and more time on developing the actual product. Before containers, when the dev team finish developing the product, they will send out an artifact and a set of installation instructions. Then, the operation team will install the artifact in the server for deployment. However, since the server may have different operating system than the dev team, this is prone to errors. Also, the instructions may miss some information, so there will be a lot of back and forth in communication between the operations team and the dev team, which creates an inefficiency in the deployment process. But with containers, the operation teams only need to download the image from the dev team and run the container in the server. Less work is needed and fewer errors will occur. As I mentioned before, Docker is a virtualization tool. But how is it different from a virtual machine? The difference is in the part of the operating system that it virtualizes. An operating system consists of two layers: the application layer and the kernel layer. The application layer is used by end user software such as web browsers and email clients. It provides protocols that allow software to send and receive information and present meaningful data to users. The kernel layer acts as a bridge between the application layer and the hardware of the system. Docker only virtualizes the application layer, while virtual machine virtualizes both the application and the kernel layers. So this creates three fundamental differences. First of all, Docker image is very light. A Docker image usually takes several megabytes, while a virtual machine takes up several gigabytes. Secondly, loading a Docker image is faster because it only handles the application layer, while loading a virtual machine is very slow because it needs to boot up the kernel as well. And finally, because virtual machine virtualizes the kernel, it is compatible with all operating systems, while Docker is only compatible with Linux distribution. Because Docker only compatible with Linux distribution, so it creates a compatibility problem. So let's say we have a Mac user And that means in his machine, he has an application layer of Mac OS, the kernel layer of Mac OS, and the hardware of a Mac machine. When he downloads a Linux-based image from Docker, because Docker only virtualizes the application layer, the image cannot use the kernel layer. So he cannot create a container from the image. The solution for this is using Docker Desktop. So Docker Desktop uses something called a hypervisor layer, which provides a lightweight Linux kernel to run the image. So I talk a lot about Docker images and Docker containers. So what is the difference between a Docker image and a Docker container? A Docker image is a blueprint that stores the source code, the dependencies, and the operating system configurations. While a Docker container is a running instance of that image. Whenever you create a new container, you basically create an isolated container environment to run the application in your machine. That means with a single image, you can create multiple containers. The next concept I want to mention is Docker registry. So a Docker registry is a place that stores Docker images. And the most famous registry is Docker Hub. I will show you that in a coding walkthrough. So what is the role of Docker in real life development? So let's say a team is developing an application using ProgressSQL. Then they can use Docker Hub to pull an image of ProgressSQL to their local machine. Once they finish the code, they can commit the code to Git, and then it will trigger the CI/CD pipeline. The CI/CD pipeline is gonna build an image, and then it's gonna push that to a private registry. Usually, companies don't push the image directly to Docker Hub. They will have a private Docker registry to maintain that. And when it comes to deployment, the server will download the image of the application from the private registry, and they will also download all the dependencies. So in this case, ProgressSQL from Docker Hub, and then run the application on the server. That's it for the conceptual overview. I will see you in a coding example. Welcome back to the coding example. The first thing you need to do is to install Docker Desktop on your local machine. You can find Docker Desktop by doing a quick Google lookup. Click on this website. So this is the main website of Docker, and it has a button here that allows you to download Docker Desktop to your machine. So depending on the operating system and the chip that you are using right now, you can choose the corresponding version. I already installed Docker Desktop on my machine, so I don't need to do that anymore. So once you install Docker Desktop, you can open it up. Here's the UI of the application. So the first tab is called the Containers tab. So this will show all the running containers in your local machine. The second tab is the Image app. So this will show all the images you have in your local machine and all the images you have in Docker Hub. So currently I have 2 images. Next, I want to show you Docker Hub. This is a very popular Docker registry. You can find almost any Docker image on this website. So this is a search bar here. You can search any Docker image you want to use. So let's say I want to find a version of Nginx. So Nginx is a very popular web server. So when you do a quick search, you can see that it will show you a list of images of the software you're trying to use. And each image will have something called a badge on the right of its name. I highly recommend you choose the Docker official image badge because these images has been verified by the Docker team and they are very credible. I will choose this image. Each image have a bunch of tags. So these are all the tags of that image. Each tag is a version of the Docker image. So you have 1.26.1, you have 1.27.0. In order to use these images in your local machine, we need to pull it using Docker pull command. I'm going to show it to you now. So to use Docker, you need to open up a terminal. It can be an IDE terminal or terminal in your local machine. It doesn't really matter. So here I'm on the terminal of VS Code. To check If you have any image in your local machine, just type in Docker images. So currently, I don't have any image. It doesn't show me anything. So to pull an image from Docker Hub to my machine, I can run Docker pull and then specify the name of the image. So Nginx. So Docker will pull that image to my machine. So to check if I have that image again, so run Docker images, and it shows that I have an Nginx and the latest version of Nginx in my machine. So the default tag for any image is latest. You can also download a different version of the same package in your machine. Let's say I want to have this version in my machine. So what I can do is copy the version, then run Docker pull Nginx : then the version name. So when I run Docker images, I can see that there are two versions of Nginx in my machine. The first one is the latest version, and the second one is 1.26.1. So now we already have our Docker image. The next thing to do is running a container using these images. To run a container, I need to use the command docker run, then specify the name of the package and the version or the tag. So I'm going to run docker run, okay? Then the name of the package is Nginx, then the version. Hit enter. So you can see that Docker just start a new web server, but I want to have my terminal back. Right now, the web server is occupied in my terminal. So how can I do that? So the first I need to do is I need to stop the web server. Now I will run the same image, but here I will put in -d. So -d means we run the container in detached mode. That means Docker will run the container in the background and give the terminal back to us. Okay, so you can see that a container is created here. So when I check Docker PS, I can see that there is a container running. How can we stop a container? So in order to stop a container, we can run docker stop and then specify the container ID. Okay, so now when I run docker ps, we no longer see that in the running containers. But notice that when we stop the container, we don't actually remove it from our machine. So if I run docker ps -a, so this will show all the containers that we have in our machine, including running and stopping containers. So you see that there are two containers that exit. One exited 26 seconds ago and one exit a minute ago. We only stop the container. We don't actually remove it from our machine. So in order to remove a container completely from our machine, we have to use the Docker Desktop UI. So when I click on this is a tab for all the containers. So to remove it, I need to click on delete, then delete forever, delete, then delete forever. So now when I come back to the terminal, I type in docker psa. I will not see any container because they are removed from my machine already. That's good enough for most of the basic command in Docker. The next thing I want to do is I want to containerize an application. So I have prepared some code here. So I have a file called index.py. So this is a very simple Flask application. It only has one route, which is a dash. And this will show me a string called hello bell. And this web server run in localhost. And the port it's running on is 3000. So let's try this. Python index.py. Okay. So now when I visit this, I can see that there's a string called hello bell. So how can I containerize this into a Docker image? First, I will hit Ctrl+C to stop the web server. In order to containerize an application, we need a Docker file configuration. I will create a new file, name it Docker file. So the IDE automatically recognizes that this is a Docker configuration file. So the first thing in this file we need to write is the base image we want to build our application on. So I will call that from and then specify the name of the base image. So it's gonna be Python because this is a Python application, colon, then the tag name. So let's see what Python version we have in Docker Hub. So I think I'm gonna use this version 3.8.19, Alpine 3.19. So the next thing is we need to specify the working directory of our project in the Docker image. So work directory, you can use a dash here, represent current folder, but usually you will need to put your code in a separate folder. So I will call that folder app. So once you specify the folder in a Docker image, we need to copy everything we have in our local machine to that folder. So I will run copy dot. So dot here means the current folder. So it will copy index.py and requirements.txt to this app folder. So /app. Once we have our code on point, the next thing to do is install the dependencies. And in Python, we usually store all our dependencies in the requirements.txt file. And in order to run it, we need to run the pip install command, right? I already run that in my local machine, but I didn't run it in the Docker image. So I'm gonna do that now. Run pip install r requirements.txt. Once I install all the dependency, I will run the command. So the first command is Python. The second command is gonna be the file that we want to run. So index.py. That's how I run the application in my local machine. And I will replicate this in the Docker image. That's it for the image. Let's recap what we are doing. So we build our application on top of a base image. In this case, it's a Python image. Then we create a directory for our image. Then copy everything from our current folder, from our source code, to this new folder. And then install all the dependencies that the application is using, then run the application. So in order to build an image, we need to run the command docker build. So docker build, then -t. So -t means we specify the tag name of the application. Next, we're gonna specify the name of the application. So I'm gonna call that btn6364 / Python Flask hello bell. Okay, then colon, then specify the tag name. So the version is gonna be 0.01 release. And I need to specify where the Docker file is. So Docker file is in the current directory. So I will put a dot here. So let's run this. Docker will build an image for me. So after Docker finishing building the image, I can check if there's an image in my local machine or not. So Docker images. So there we go. We have an image called Python Flask hello bell, and the version is 0.0.1 release. Once we have the image, we need to run it to see if it works or not. So I'm gonna call docker run, right? Run that in detached mode and specify the name of the image. So this is the name of the image, colon, then the tag name. So 0.0.1 release. Hit enter. All right, so now a container is created. I can test that in my local machine. So let's run this. Oh, it doesn't work. So the reason why it doesn't work is even though we specify in the application that the web app will run on port 3000, but this 3000 now means it only runs in port 3000 in the Docker image. It's not connected to my local machine. In order to connect this port 3000 of the Docker image to my local machine, I need to run a different command. So first of all, I need to stop the container. Then using the docker run command again. But this time I will add in a different tag called -p. In -p, the first thing we need to provide is the port we want to connect in our local machine. So let's say I want to connect at port 8000 in my machine. And the second thing is the port we want to connect in the Docker image, which is port 3000. So now let's run this. The application is running. So now when I go to localhost 8000, the application is working again. That's how you run and containerize an application in your local machine. The next step you can do is to push this image to a remote server or a Docker registry. In order to do that, very simple, just run docker push and then provide the name and the tag of your Docker image. When I go to Docker Hub, I can clearly see that there's a Docker image called btn6364 python flash hello bell. Anyone on the internet can download this image to their local machine. That's it for this video. I hope you enjoy it. If you like the video, please like and subscribe. That supports the channel a lot. And I will see you in the next video. Peace.